Today we're going to talk about heat. Heat is a form of energy. So when you add heat to an object by putting it over a fire, you're adding energy. But what happens to that energy? Where does the energy go? One of the things that can happen when you add energy is objects can melt. So here's the surface of the ice cube, and it's melting because of the energy from the sun. In addition to melting, something that can happen is you can boil water when you add energy. But before you get the water to actually boil, first you'll have to raise its temperature. And how do you raise the temperature? By adding heat. So there are two different things you can do when you add heat. You can cause an object to rise in temperature. It can rise in temperature, or you can make it change from one phase to another by melting or boiling. Now I have to give credit, this video is actually called How to Boil Water. So when we add the heat, when we add the energy, two different physical effects can occur. You can change the phase, like melt or boil, or you can cause an object to rise in temperature. It can warm up. But this raises a question. When you add energy to something, the energy can't be destroyed. Just like energy can't be created. It can only change form. So when you add heat from a flame into your water, what new form does that heat take? Where does the energy go? The answer is that the energy is added to the molecules. So what does that mean? It means the energy becomes, the heat becomes internal energy. But we've learned that internal energy has two types. Molecules can have kinetic energy, molecules can have potential energy. So which of these increases when you heat an object? Well, it depends on whether the object rises in temperature or whether the object changes phase. Take a guess. When the object rises in temperature, what do you think changes, kinetic energy or potential energy? When an object changes phase, what changes, kinetic or potential energy? Where does that heat energy go? To answer this question, we have a video that's going to help, two videos. In this first video, we're going to raise the temperature of the gas. Now, this is a gas, and we're going to raise the temperature by exposing it to this really hot wall over on the right side. So this is a hot wall, and watch what happens as the temperature rises. It's getting a little hotter, getting a little hotter. The red indicates hot. It's getting hotter still. Watch over on the right wall. What's happening on the right wall? What's making things get hotter? And now it gets hotter and hotter, more and more red. And what you see is that when we raise the temperature, we are adding heat and changing the kinetic energy. The kinetic energy is increasing. That's where the heat goes when you raise the temperature. What about when you change phase? Well, here's a crystal, and we're going to watch what happens when it melts. Remember, to make it melt, we have to add energy. So what is our energy doing? Is our energy making the molecules go faster, or is it making them get farther apart? So we're still in the melting process. We have to keep watching. Are the molecules moving any faster as they melt? Well, here we go. Now they're melting. What we see is that the molecules don't move any faster. They simply move farther apart. So by moving farther apart, we increase their potential energy, just like a ball getting higher off the ground. So what have we learned? Adding heat, and we call heat capital Q for the number of joules of energy we add, adding heat increases the internal energy. When the temperature rises, the heat is increasing the kinetic energy specifically, And when the phase changes, like melting or boiling, the heat increases the potential energy. We know the kinetic energy rises with temperature because molecules moved faster in the simulation. We know the potential energy rises when the phase changed because those molecules moved farther apart.